What I'm going to do is just remind you of the negative indices, because we did those the other day. So if I have x to the power of -3, would someone like to remind me what that really means? For now, what do you think? Why did you put your hand up, Ethan? Oh, okay. So I mean the negative part of it. Kimberly, it's in the wrong place, which means where should it be?
On another number.
Yeah. Be more specific. What do you mean by another place? Under what? Oh man, guys, I'm looking for a word. Ethan, what's the word I'm looking for? Good. Okay, so it's a fraction I'm looking for, guys. 1 over x cubed, right? The negative power, like Kimberly said, means it's in the wrong place, which means it belongs on the other part of the fraction. The place is that's placed in the fraction. So if I said 2x to the power of -4, what would I do with this one? Aditya, what do you think?
So 2, 1, 2, and then fraction 9, and then x to the power 4.
Good. Okay, so remember, only the bit with the negative power is in the wrong place. So if I gave you something like x to the power of -2 times m to the power of -3 times y to the power of 5, what would I actually do with that? How would I write this as simply as I can? Pranal, what do you think?
1 over x to the power of 2 times 1 over m to the power of 3.
I mean, why would I separate them? Right? Seems unnecessary. Victor?
Y to the power of 5 over x to the power of 2 and
Not negative.
no, I mean, and the power of
It's not negative. So once you move it, the negative goes away, right? So the y, so remember, I did not need to put in these signs. This means that they all just belong next to each other. I just put in the signs to be annoying. You don't need them. So that's why the whole answer is, whoa, careful, one term, right? So I'm leaving the y on the top and I'm putting the x and the m down the bottom because they were the only bits with a negative power. So when I, why don't you put it on the actual carpet? Otherwise it's just going to keep falling. Or there we go. All right. So that's basically what we're doing with negative indices. So that's just a reminder of that. Let me save it. Okay. Oops, don't do that. All right, so let's now talk about fractional indices. These are the really hard parts. Let's not do that. All right, so let's start with the easy version. So m to the power of a half, right? This is the really simple one, which is just one of the ones I want to have off the top of your head, right? This is the one that everyone should know. Whether you get the rest of the topic or not, we should all remember this one fact. Aditya, what is another way of writing m to the power of a half?
M cubed.
Do we not remember?
Square, yeah, m roots, sorry.
Right, it's a square root of m. So this is the one fact everyone should know. This is the easy bit, right? This is just a fact I want you to know. If it ever says m to the power of a half or anything to the power of a half, it means square root. So if I said 9 to the power of a half, that means root 9, which is 3, right? So if I had 16 to the power of a half, that means root 16, which means 4, right? This is the one that everyone's going to get. It's when we change the numbers that it starts to become a little bit more challenging. So let's work with a 3 because we already know some cube numbers as well. So if I say m to the power of a third, instead of a square root, what do you think it's going to be? Cubed root. So if I have 8 to the power of a third, how else can I write that? Aditya? Cubed root of 8, which is 2. Good, because 2 times 2 times 2 is 8, right? So the cubed root of 8 is 2. Whatever number times itself 3 times. All right, so what about 27 to the power of a third? Is the cubed root of 27, which is 3, right? 3 times 3 is 9, times 3 is 27. All right, so you can imagine where this is going, obviously, right? I'm going to change color. So if I have, let's just do it over here. So if I have m to the power of a quarter, I'm sure we can all guess what that's going to be. Can we imagine what's going to happen?
4 rooted.
It's the 4th root of m, right? Yeah. Oh, yeah, you were just going to say that. So it's a 4th root of m. So what if I had something like, yeah, 16 to the power of a quarter is the 4th root of 16, which is
2.
2, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. So the 4th root of 16 is 2. Now, they are not going to expect you to know the 4th root of 127,402, right? No one's going to ask you to do anything like that. That's not the thing. They're going to ask you to rewrite them using powers and roots. That's the bit that you have to learn to do, not how do you work out the 5th root of something in your head. That's not the point of any of this. All right, so basically, I'm just trying to get you to get used to the different ways of writing. Now, this becomes trickier when 1 becomes a higher number than 1. So let's have a bit of a look at the general rule. So I'm going to save that. I'm going to put all these screenshots on Google Classroom, okay? So I'm screenshotting all of the things that I'm doing here. You'll have access to all of them. So the general rule is a to the power of m over n is the nth, well, I've written the n differently. That's not very helpful, is it? The nth root of a to the power of m. All right, now, it does not matter whether you do the m on the a before you root it or afterwards, but I'm suggesting that you do it afterwards because it's mathematically easier. So let me give you an example of what I mean. So you basically take the fraction, whatever number's on the top goes over here, and whatever number's on the bottom goes over here. That's all you have to do, right? Just find the two numbers and attach them to the other side. So if I have m to the power of 2/5, you don't need to be able to work this out. I'm not asking you to work it out. I'm asking you to rewrite it. So that means the bottom number, which is the 5, goes outside the root sign. So this is a 5th root of a, and then we square the answer because the 2 was on the top of the fraction. Does this make sense? So this bit's okay. This bit's just rewriting whatever there is. It becomes tricky when I'm actually giving you numbers, but with letters, it's actually fine. Yeah.
Where did the A come from?
I've turned the A into an M. Sorry. Yes, very good. Very good. M has become an A because I'm an idiot. Sorry. I was just copying the A from up there because my brain is dead at the end of the day. Yes. So we should have whatever the base is, whatever this base number is, belongs there. Bottom number goes on the top. Top number goes over here at the end. So let's try something with an actual number that's actually, let's do another one with letters and then we'll do a number, but an easy one. Okay, so let's say that I have h to the power of 3/7. Who wants to have a go at telling me how I should rewrite that? Kimberly, what do you think? The square root sign?
And then the 7 on the outside.
7 over here.
And then H. And to the power of 3.
Perfect. That's exactly right. All right. This time I've got b to the power of 8/5. Who wants to have a go at telling me this one? What would I do? Pranal, what do you think?
B to the power of 5. No, B to the power of 8. And B to the power of 8. 8 rooted.
Okay, that's not powers, right? That's a 5th root. So just make sure you're using the right language. This is the 5th root of b. It's got nothing to do with to the power of, okay? And then what?
To the power of 8.
Right, now it's to the power of 8. Good. Okay, why don't we put a number in here just so we can see what it looks like? But at the moment, that is the answer, right? We're just rewriting it. So what if I said 8 to the power of 4/3? Okay, who wants to tell me how I can rewrite this? Hannah, what do you think?
Is it cubed root 8 to the power of 4?
Absolutely, it is. Well done. All right, so what is the cubed root of 8? Yell it out.
2.
2. So this is 2 to the power of 4, right? Because the cubed root of 8 is 2. And then what's 2 to the power of 4?
16.
16. So the answer to 8 to the power of 4/3 is 16. See how when we do it step by step, it's not that bad? So I promise you there will be something like this on your exam next year. They always do stuff like this, but sometimes they give you pretty decent versions. Sometimes they're kind of mean to you, but it's really just a matter of understanding this basic rule. How do you rewrite the question? And then you can solve it one step at a time. So I also want to tell you another way to do this, which is completely insane. So 8 to the power of 4 is 4,096. And then the cubed root of 4,096 is 16. So see how they're both the same answer, but this way was so much easier, right? So that's why you shouldn't do this before you do the rooting, right? Don't do the power before you do the root, because otherwise mathematically it's really difficult, but it will still work. It's just much harder. So I do not recommend this version, even though it technically works. This version, much, much easier. Okay, now there's all sorts of horrendous things going on in this. So I'm sorry to say, but that's still the easy part.
What?
I'm very sorry.
What's the hard one?
Exactly. Who's got a tissue box? Okay. So now we're going to try and combine some of our skills. So I have m to the power of 1/3 times m to the power of 2/5. What do you think I should do first? Kimberly, what am I doing first?
Make the have the same denominator.
Good, because why am I bothering to do that? That's not, okay, I need to add them together, right? So I have to make the denominators match because the rule is that I have to add these fractions together, right? So now, what am I multiplying this one by? 5, and this one by 3. So what do I get? M to the power of what? Yeah, what goes on top? 5 times m to the power of? Good. Okay, now what? If I put them together, I get? Okay, so I add them together. Now, if I rewrite this as a root, what do I do?
To the power of
15 goes on the outside.
15
And then
to the power of 11.
the power of 11.
Okay, obviously we can't do anything with this, but we've rewritten it. So this is what I mean about multiple steps. So they're going to ask you to use this fractional idea as well as a lot of the other stuff. Yeah. Mostly, it's getting a little worse.
Oh, wait, is the hard work coming up stuff?
No, this is still very hard. It's just there are there are equally hard bits. This is still the hard bit, yes. Okay, so then